Hello, this is Team 22034, and we have been tasked with designing and developing an elephant pellet dispersal unit for Reed Park Zoo. To introduce the team members, my name is Gabriela and I study mechanical engineering. Alejandra studies industrial engineering. Tyler studies mechanical engineering as well. Devin studies electrical and computer engineering. And lastly, Angel studies electrical and computer engineering. Elephants are naturally foraging animals. Our team wanted to create a more realistic experience for the elephants in the Reed Park Zoo. We wanted to design a device that was easy for the zookeepers to use, withstand weather conditions, and keep the elephants and zookeepers safe. Currently, the zookeepers throw elephant pellets into the habitat, but is limited to the distance that the zookeepers can throw. Our plan is to utilize a programmable pneumatic launching device that can project pellets to elephants at different distances. After consulting with our sponsor, here's an example of some of the major system requirements for the dispersal unit. One of the requirements is to reach a maximum distance of 60 feet and a minimum distance of 20 feet. Another requirement is to have both automatic and manual launching settings. With safety as our main priority, we wanted to make sure that the device would not be harmful or cause any distress to the elephants. We also wanted to make sure that the device would not be affected by Tucson's varying weather conditions. In order to achieve the system requirements, the team came up with 3 different ideas for the device, with the spring and pneumatic powered systems being the most favored. The team started off designing a spring-powered system because we were not sure if the elephants would be affected by the air compressor that was needed for the pneumatic system. We ultimately decided to change the pneumatic system and tested to make sure that the air compressor would not be disrupted to the elephants. This ended up being the optimal options because the pneumatic systems gave us the distance and the power needed to launch the elephant pellets in the correct way.
The first critical component of this device is the launcher, which is depicted in the picture here. As you can see, it's a series of pipe and valves that connects to a compressor and allows for the pneumatic system to launch pellets. As seen in this picture, the launcher is placed at an angle as to maximize the distance that the pellets can travel with a given compressed air load. You can see here the implementation of the launching sequence with the compressor connecting to the valve portion sticking off the side, and then the other solenoid valve, which is larger, that allows air to flow from the storage tank into the barrel and drive the pellets outward. Here's a video of the actual launch. Here we show that the pellets have a very large spread coming from this device, which is a good thing. The idea being that it will increase the randomness and therefore the distance the elephants have to walk and effort they have to put into finding the food. In order to effectively give the zoo choices for power options, we use an average since the spread is so large. We also want to discuss the safety of the pellets themselves. Obviously, we cannot control where the elephants will be at the time of the launch, so we want to make sure that the pellet velocity is safe if it were to hit an elephant. The launcher sits inside this wooden frame and is held from slipping with a rear plate of wood that covers the entire end cap of the launcher. This entire mount with the launcher sits on a rotating turntable in order to accommodate the autonomous requirements. The turntable needs to rotate in both directions so that the launcher may collect food from the dispenser, rotate out to a given launch position, and launch the pellets. It then needs to rotate back to the dispenser. With the turntable and launching apparatus designed and built, we now move on to the dispenser. This is where members of the zoo will fill the pellets into a large hopper on top of the dispenser. Then, when a signal is received from the Arduino to run the dispenser, it will dispense pellets into the barrel of the launcher to prepare for a launch. Now shown is how the components will be arranged inside this structure. We can see the compressor and the launcher here, followed by the location of the dispenser, with plenty of room left for various electronic components and wiring. There will be a slot cut in the outside of the frame, that is the OSB and the siding, in order to ensure that the pellets can exit the structure without hitting any portions of the structure.
Here is an aerial view of the elephant habitat. As you can see, there are 4 marked locations, 1, 2, 3, and 4. The launcher will be placed right in the center of these 4 locations. The goal is to be able to launch pellets within these 4 locations in a scattered and random motion, so that way the elephants can reach the pellets.
A significant part of our project, which will help the zoo staff, is the ability to make the launches autonomous and programmable. The zoo staff will be able to input different launch times and distance settings in the morning, so the launch sequences happen automatically throughout the day, without the need of staff having to manually go and feed the elephants. The launch times and settings will be inputted through a touchscreen, which will have a menu. The launching queue can also be displayed on the screen. The touchscreen is connected to our microcontroller and will communicate when to initiate a launch through 2 serial communication cables. All of the other components previously talked about, such as the rotating turntable, solenoid valves, food dispenser, and air compressor, are going to be connected to the microcontroller through a relay switch module. The microcontroller will then control when the air compressor is on and when the valves have to open to complete a successful food launch. It will also control the rotating turntable and the food dispenser, so the entire process is fully autonomous.
On behalf of the team, I would like to thank you all for watching our Design Day video. We would also like to thank Stephanie, our sponsor, and the Reed Park Zoo for giving us the opportunity to design this device for the elephants. We would also like to thank Scott, our mentor, for helping us along the way. Thanks again for watching.